Happy to see so many faces, many of you faces I know. Digitalization, I think this is the word of the decade. Everything is getting digitalized. Digitalization is coming into public transport, into healthcare, monetary system. Even last time when I went to the library, the librarian told me they don't have a hard copy, but I can use my profile and access the digital version of the book. So my colleagues and I decided to take a look of this process of digitalization, how it is going on and evolving in the area of geological and geotechnical monitoring. So digitalization is an evolving process. We already passed the digitization process and we are really now staying in the digitalization where we already get digital information and we are storing and viewing it in digital databases. And with this, we are setting stepstones for the digital transformation, which will be the next step. In geology, before we used to do analog face mapping. Many of you older colleagues and even I, when started doing face mapping, we just had a piece of paper with us and a pen. You went to the face, you did your sketch, you took the information, and then this was done. Then slowly we started by scanning, and then the next step was copying the data from the paper to a digital database, and then slowly it started evolving the database for digital face logging. There, this is where we are now. Currently, we are already doing digital face logging. We are also collecting 3D geological data through photogrammetry, which already Tilan made a great introduction in the previous lecture. And we are building the 3D geological model. Anyway, the development of this digitalization is going and is setting into the direction where we'll be able to implement this data in a bigger digital environment where the information will be also available for other parties involved in the construction. Similar with geotechnical monitoring, before the monitoring was done manually, the engineer doing the measurements, then manually calculated, did the graphs. Soon after, with the all-purpose Excel, everything was transferred there and the graphs were made in Excel. Reports were made manually and then printed out in PDF and submitted to whoever needed to go through them. So whoever was doing the monitoring and had to check all different reports and somehow get this information on the same level and then evaluate it. So a process of stepping forward was with the programs which were mainly provided by the providers of the measuring equipment, where crude measurements could be imported directly into the programs and then evaluated in the program, and also the report could be generated in the program. So this was an in-between step from where we are now. Now we have the possibility of automatic gathering of geotechnical measurements going on. We have a central storage base and we have available them anytime from anywhere. And again, the future, we see that all this information that is now for geology in one database and for the geotechnical measurement in another database will all be sooner or later available for connection in a bigger digital environment where all this information will connect to the other information, for example, the information of the construction and excavation, and all this data and information will be able to interact and to connect. Okay, so our focus was mainly on the digitalization going on that we are doing with the monitoring of the Karavanke Tunnel. You already heard a lot about the Karavanke Tunnel, so I won't be too long here. What I would just point out that the excavation of the second tube started a little bit more than a year ago. We have already successfully passed the moraine sediments, the Triassic carbonate sediments, and the Permian clastic sediments, and we are now slowly getting into the area to the Carboniferous part. We are now around 1.5 kilometers inside the tunnel. Geological monitoring is going on digitally. We are making digital face maps. Along with digital face maps, photogrammetrical scanning of the excavated face and the excavated area is going on. And the information from the photogrammetrical scanning is used as basis of the digital face log. The face log is given all attributes such as faults, ground types, and other discontinuities. And it's also used for 3D modeling of the excavated area. This 3D geological model that is being constructed is also implemented in the existing 3D geological model and is helping us to get this 3D model more accurate and better for prognosis. The geotechnical monitoring, we have installed a couple of measuring sections. The measuring sections are connected to the data logger, which is through internet and modem connected to a central server. So the automated measurements can be directly transferred from the data logger directly to a central database where it's accessible via Kronos. We use Kronos, which is from Geodata, and can be reviewed and analyzed and worked with in real time, anytime from anywhere. We also have some measurements will still need to be imported manually. These are mainly inclinometers and geological 3D, geodetical 3D points. And also some measurements which are not compatible yet with this database, like vibrations, where reports are made regularly and still imported as PDF on this database. So here are a few points of the advantages that we find during doing this geological and geotechnical digitalization and monitoring. For geology, I would point out that this visualization that we get by building a 3D geological model is really helpful and is also helpful in prognosis and prediction of structures in front of the face. And of course, a big advantage is also that we get a 3D geological model of the excavation available even after the excavation is finished. In the geotechnical measurement side, except for having this information available anytime, anywhere, the advantage is, let's say, for less visits to the site, which means that it's less disturbance in the excavation process. Once the monitoring system is installed, it is automatically registered and measured and transferred, and there is no need to visit the tunnel again to collect the measurements. Possibility of alarming, this is also a big advantage. We haven't used it yet, which I guess is very good. But with going to the Carboniferous part of Karavanke, where we expect greater deformations, this feature will probably be of great use. So alarming enables the geotechnical supervisor or engineer or designer to be informed immediately whenever there are some measurements over the predicted measurements. So anytime when anything strange is going on in the tunnel, when the deformations are too big, where there are critical phases, the alarming notifies whoever needs to be notified, and the reaction can be very fast. So this is a really good feature, and we hope we will not have to get to use it a lot. Here I pointed a couple disadvantages. For geology, the little bit disadvantage is the unstable conditions, because when the photogrammetry is going on, we need a full face, the face prepared in a special way. And in unstable conditions, this is not available. So we have not had such a situation yet. This is again something we are expecting to get in the Carboniferous part of the tunnel. And it's a challenge for waiting for us to see how we will manage with this. And of course, we need the face prepared in a certain way, and a small stop has to be made in this excavation, so we are a small disturbance in the excavation process of the contractor. Geotechnical measurement side, the disadvantages are more technical, like the coverage of web in tunnels, maybe some shortage in electricity supplies, which affects this constant measurement transfer to the server. Damaging of equipment, of course, this is a rough environment. Excavators going on, blasting going on, and of course, damages are to some extent inevitable. And like I mentioned before, there are some measurements we cannot yet directly implement to this database and have to be either imported manually or imported as PDFs, uploaded as PDFs, and made separately. So this is what is still needs more development. Okay, just to take the line and to give you a few conclusions. The data is stored in one place and instantly available. This is a big advantage, I think. Also, the storage in one data enables us to review, to work with the data, to analyze the data, and also to adjust the data in a way we need it to get the most of the interpretation we need for our further works. So it really gives us a lot of free space on how we want our measurements to work for us. The setup of such a database we found is quite time-consuming, and it needs to be really thought, and this needs to be done before the project starts. Once the database is set, there are very limited options of correcting it. So this is something that is really crucial to be done well in the in the stage of pre-excavation, before the excavation starts. Like I said, the face needs to be prepared in a certain way. Measuring elements need to be installed, and for all this we need the cooperation of the contractor. We are also a small disturbance. This is also something that needs to be considered in the contractor's workflow. And protection of the measuring equipment, another big factor. If we want to get quality measurements and continuous measurements, the equipment needs to be well protected. And of course, further development is needed to implement more data into this monitoring, digitalized monitoring. Okay, just before I finish, a few recommendations for future project. Like I said before, the importance of a good database, to have it set, to have it thought through before the project starts. And this is quite time-consuming and also costly. And it's sometimes hard for the investors to understand that this is a really crucial part and we need it done before the excavation starts. Possible solutions to protect the equipment from physical damage. Maybe here we have a suggestion that it could somehow be implemented in the design phase when the design for the measuring section is being done. So to include some solution that could also include the protection of the, let's say, data logger. Of course, better web and signal coverage in tunnels is required, but this is something that probably with the ongoing time will get better and better. Another crucial point are the users. The users need to get familiar with the program, and you need to get to know how to use it so that they can exploit the full potential of the program. I know it's hard and every change is hard, but once you get into it, it can bring great benefits. You can really adjust the information you need in a way you need it, and this can also then affect the reduction of cost and time. So, this brings us now to the end of my lecture. I would like to thank you for your attention.